wavelength. We have actually learned wavelength in the previous video in wave concept part 2. So let's revise. So wavelength is actually distance between 2 points that are in phase. Last time in the last video we say that the distance between a crest to the next crest is called wavelength. Yes, because why? Because crest and the next crest and the next crest, these are all points that are in phase. Therefore, from one crest to the next crest, this distance is called wavelength. So if it is transverse wave, then we say it is from crest to the next crest, trough to the next trough. But if it is for longitudinal wave, then we say it is compression to the next compression. So in general term, so a wavelength is distance between 2 points that are in phase. Okay, crest to the next crest, trough to the next trough for transverse wave. For longitudinal wave, crest compression to the next compression, the middle, the midpoint, and the midpoint of the next compression. This is called wavelength. The symbol of wavelength is lambda. This is lambda. Okay, so let's compare. So transverse wave and longitudinal wave. So crest to crest wavelength, trough to trough wavelength. For longitudinal wave, compression to the next compression wavelength, rarefaction to the next rarefaction wavelength. Okay, one complete oscillation or one complete cycle. What do you mean by that? So if I have pendulum, this is the equilibrium position. So if I displace it to A, so A is called the starting point, and then I let go. So the pendulum will oscillate from A, it will go to equilibrium position, then it goes to B, and then it comes back to equilibrium position, and then goes back to A. So from A, it goes to B, and then comes back to A. This is called one complete oscillation. For mass on the spring, also same thing. From the equilibrium position, if I displace it, if I pull it, I stretch it to A, and then I let go, so the mass will oscillate between B and then it comes back to A. So from A, it goes to B and then comes back to A. This is called one complete oscillation. Take note, it is not from A to B. From A back to A is called one complete oscillation. Same thing as a pendulum. From A back to A is one complete oscillation. So I can draw one complete oscillation from this equilibrium position to this equilibrium position, not to this one, this to this, this to that, or from trough to the next trough, or crest to the next crest. Okay, or we can say that two consecutive points that are in phase, will be one complete oscillation. Okay, these 2 points are in phase, consecutive, one after another. So from here to the next point that is in phase is called one complete oscillation. That's why from here to here is not one complete oscillation, because this is not in phase with that. Clear? Okay, next term is frequency. Frequency is the number of complete oscillations made by a system in 1 second. In 1 second, how many complete oscillations made is called frequency. So the unit of frequency is hertz. Symbol is Hz. For example, here, I start from this equilibrium position, this point that is in phase. So it is from here up and then down and then come back to equilibrium position. So this is one complete oscillation. So this is one. The blue wave here is one complete oscillation. Then the red one is one complete oscillation. Then the blue one is another complete oscillation, and the green one is another complete oscillation. Therefore, there are 3 complete oscillations that makes up 3 Hertz. So let's look at these two graphs. Let's make a comparison. So this one, let's say from here to the end is 1 second. Yeah, same thing here. 1 from here to there is 1 second. So the same time in this graph, the upper graph here, how many complete oscillation it has made? See, you can count 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it is 9 Hertz. This one, 1, 2, 3, 4, 4.5 only. So that's why it is lower frequency compared to this graph here. Okay, let's look at the graph again. Now look at it deeper. Just now we look at the number of complete oscillation, which is called frequency. What about the wavelength? So you see this graph, this wave is of high frequency, but the wavelength is from here to there, so it's short. Compared to this wave, you see the frequency is low, but the wavelength is long, right? Therefore, we say a wave that has got high frequency wave, the wavelength will be shorter. Okay, a lower frequency wave, the wavelength will be longer. Therefore, we say frequency and wavelength are inversely proportional. All right, period. Period is the time taken for a system to make a complete oscillation. So it's a time period. Period tells us time. How much time does it take to make one complete oscillation? So because it is time, so the unit is second. SI unit is second. So you see, if the x-axis is a time axis, so you see from here, equilibrium position to this equilibrium position is one complete oscillation. So you see it is 4. So the period is 4 seconds. Yeah, so 4 seconds. So another complete oscillation, see here, so 8. So 8 minus 4 is also 4 seconds. So this graph, the period is 4 seconds. Okay, so frequency is what? Number of complete oscillation made by a system in 1 second. But period is the time taken for the system to make one complete oscillation. So these two are related to one another, isn't it? Okay, so in fact, period, capital T stands for period, is inversely proportional to frequency. So a wave that is of high frequency, the period will be short. A wave that is of low frequency, the period will be long. Yeah, the period will be long. Okay, so I repeat, frequency and period, they are inversely proportional to one another. Okay, now if it is sound wave that is of high amplitude will be loud sound. Therefore, amplitude is related to loudness. A wave that is of high amplitude will be of loud sound, will be louder compared to a wave that is of lower amplitude. So it will be quieter. But frequency is related to pitch of the sound. A sound that has high frequency will be of high pitch, like a soprano singer, high pitch. A sound wave that is of low frequency will be of low pitch. Example, a bass singer, right? Low pitch. Okay, so I repeat, amplitude of a sound wave is related to loudness, as compared to frequency of sound wave is related to pitch of the sound. Okay, we will stop here, we'll end here for this lesson, and we will continue further. See you again. Bye.